Hello everyone, in this video we are going to see linked list merge two sorted linked list. We are given two linked lists which are all in ascending order, incremental order, and we have to merge these two linked lists so that the new list also is sorted. Okay, here you can see 100, 300, this is an odd numbers, and here even number like 200, 400, 600. So once we merge this, it will be like 100, 200, 300, 4, like this it goes. You can see this pointer is pointing towards the incremental nodes. So how do we solve this problem is, this is my code snippet going to help me to solve this. This code is with dummy node. This with dummy node means we're creating one dummy node, and we're doing this operation. So you can do it without dummy nodes also. So we'll see how do we do this. First, I'll create the dummy node, and I'll create a tail pointer. And here inside of this while loop, what I'm doing here, I'm taking this list as n1, and this is n2. I'm comparing these nodes. N1 and n2 are a pointer, list node pointers. So I'm comparing these two. Which one is a lesser node or greater node? So I'm going to see which one is less than, or you can just give a less than or not equal to. You can whatever the node is lesser, you can return that node. If n1 is lesser and n2 is greater, means you have to return n1, or else you can give it n2. Okay, that list address we have to pass, because whatever the node is coming, we can consider this one as n. Out of this we consider which is lesser. So this is 100 is lesser, so this 100 will goes as n, and with that n we'll create one more pointer called tail. So this is the tail. We are going to return it as a answer. So that's the reason is there, because that's the reason here it is assigned that address of tail to a dummy's address is assigned to tail node. Okay, tail pointers. Okay, now I have to continue this until my last node, which means both the condition should match. Here you can see one, this one and this one. Okay, what if my node goes only at this list to many numbers? At that time I have to make this tail pointers next to this node, so that these nodes are already connected. So whatever the node exists, if n1 exists, return that n1, or if n2 exists, that return to that tails next, so that my list will continues. And I have to return that dummy nodes next, because this dummy node is initialized to init min. So integer minimum value we have to give, because we're seeing for ascending order. That's the reason it is int min. Okay, now we'll implement this one in Visual Studio Code, and we'll find out the answers. Here we have necessary importings, and this is my class node definition, and this is my driver functions to write those programs, and this is main function. Here I created two lists, x and y, and I just printed this, so we make sure what it's there. Here you can see some even numbers are there, and the odd numbers are there. So we'll write program for this, and we'll find out the answer. Okay, here list node. You can name it as merge list. We need two nodes, so list node n1 and list node n2, and we need one dummy node. you can just create an instance of it, and you can initialize this to int min. Int 32 min you can give. You can give it as d dummy, and you need one tail pointer. List node tail. You can give this address of dummy to this tail pointer so that all of them get updated in this tail. Okay, ultimately I have to return this dummies next, so dummy dot next I have to return, so I'll write it. Okay, we have to continue this operations of when both the nodes are existing. Here this one 100 also exists, here also parallelly this should exist. So that's the reason it's n1 and n2 both should come, and I have to take which one is the minimum of these two. So n1 data less than n2's data. If that's the case, I have to return n1 or else n2. Okay, I need to, whatever the node it comes, I'll name it as n. Okay, now I need to update directly on that node itself, so I give address of operator here itself, and I can give this tail. Already we have one called dummy, so that dummy is next, so tail next equals this n, and a tail equals to tails dot next to travel to the next node, and n1 also should advance, because once I completed this operations I inserted this one in the tail, but that still stands here. I have to move this, but that literally referred here as n, so that wherever it can be either n1 or n2, but that whichever that list is should advance to the next position. So I'll give n equal to n dot next. This line you can write it in one line itself, equals to n, and once my operation is done when two nodes are exist, when only one node is exist, like that if we are shifting this n, it will come until here, and this n also will come until here. So until this it's fine while loop executes, but when I advances this to next, here we don't have anything, here it moved to null, and here we don't have anything. So whatever the node remaining nodes, I have to give that tails dot next, because tail is the maintaining the actual answer. So I have to give this tails dot next whatever the node, which means the n. So if n1 is there, we have to return n1, or else n2 we have to return. It's assigned to tails next. Okay, it can be null also, it can be not null also, we don't need to worry, but whatever there, it's it, in this case we have extra one node, but it can be a same one. Here also 4 nodes, here also 4 nodes, that's also possible. So whatever, we no need to worry about null here. So we have to return that dummies next, because it's initialized to min, it's relevant to the answer, and ultimately you can print this x dot, you can check of merge list, and you can pass this x and y, it return one pointer here, x dot head and y's head. And you have to print this, so start print. Okay, now run. Here you can see my list is merged, 0 1 2 3 4 5 6, like that, it's having until 9, and it got printed, so it works fine. and I'll delete some of these elements. I told you this scenario of absence of node in another linked list, and we run this again. So you can see until 4 it got merged, and 5, 6, 7, 5, 7, 9 is remaining nodes what are all there. It's coming properly. Okay. Hope you understood this problem and solution. This is a very easy solution of just 5-6 lines of code. Hope you understood this problem. This is very important problem and frequently asked during the interviews. You don't forget here this why we we take this n1 or n2 and this address of operators. So that's the reason. Okay, thank you for watching this video, and we'll meet in the next video.